we are going to do in this exercise one of maybe the simplest relation between surfaces, which is the relation of tangency between a plane and a sphere. So what we are gonna do first is we are gonna define a sphere with a fixed center and a known radius, and once this is defined, we are gonna look for a plane tangent to the sphere at a random point of the surface of this geometry. Well, so to do so, we are gonna draw first the radius of the sphere. We are gonna fix the center, and we are gonna set the dimension of the radius. I set it to 100. So now, if we move around the floating point at the end of the radius, we could visualize that it is defining the surface of the sphere. A sphere that is not visible yet. Well, so now that we have this defined, what we are gonna do is to define a plane at this point of the surface of the sphere. Well, so since this plane is going to be tangent to the sphere, what we know, or we need to know, is that the plane needs to be perpendicular to the radius of the sphere. So the first thing to do is to draw the plane. We are going to define it by means of two lines, and then we will set the perpendicular relation between the lines and the segment. We will be sure that the plane is already perpendicular to the segment. So we are gonna start drawing the lines to define the plane. We need to make the first line coincident with the point of tangency between the plane and the sphere. I'm gonna set the coincidence at the middle point of the line to avoid that when we rotate the view afterwards, any of the lines will move away. And now we see that we have the two lines intersecting and containing the point of the surface of the sphere. Now with this view we can observe that these lines define a plane, but this plane is not tangent yet to the sphere because it's not perpendicular to the radius. So this plane will intersect the sphere instead of being tangent to it. So now we proceed to force the relation of perpendicularity between the radius of the sphere and each one of the lines defining the plane. I select the first one and the radius, and I set this relation of perpendicularity, and now I do exactly the same with the second line. So now that the two lines are perpendicular, if we rotate the view, we can check that the plane defined with these two lanes is going to be perpendicular to the radius, thus is going to be tangent to the sphere. If we move the floating point on the surface of the sphere, we can see that no matter the position of the point, all these planes defined by these two lines are going to be tangent to the sphere. So we will have infinite solutions of this problem. In order to visualize both the geometries in an easier way, we are going to build now the sphere first, and then we will build the plane. So what we need to do, we need to create the plane containing the radius of the sphere, or one diameter of the sphere, and one circle of the sphere. So this auxiliary plane, we needed to intersect with the center of the sphere. So this means that the resultant curve from the intersection of this plane and the sphere is going to be a circle. So this plane needs to contain the center, as I already. It doesn't matter which other point from the ones we use to define this plane, because any plane containing the center of the sphere is going to fulfill the condition of intersecting it, generating a circle with the maximum radius. So yeah, I select this point randomly, and now we got this plane number 1, which is going to be the one on which we are going to work to draw half of a circle to then build our sphere. So on this plane, we build this half of an arc of a circle. We need to close this sketch with a diameter of the sphere. So this straight line I just draw needs to be coincident with the end of the arc, which has 180 degrees. And also if I move it, you see that it's not coincident with the center. We need to force this coincidence. Yeah, and now we got the sketch. We can rotate around the diameter, so we will be generating, doing this, our sphere. I'm gonna extend this plane so it's easier to see it. And now we proceed to the revolution. We select the axis of revolution and we got our sphere. Now if we rotate the view, we can check that indeed the plane or the lines defining the plane are tangent to the sphere. And now we are gonna define or build or make visible the plane. So now with these two lines, we define this plane containing both of them, so we have finished this problem. We change the name of the operations if we want to make it easy to remember, and if we rotate the view, we can check that this plane is tangent to the sphere as we were looking for.